Hey guys, it's Vince. Today in this video we're going to be discussing one of the most critical topics that I've yet discussed, and it's how to determine if the PC you're using is stable for CNC use, whether you're doing hobby use, recreational use for yourself, or production use, where it's even more critical. And again, as the video's title states, this video can easily save you hundreds if not thousands of dollars, especially with time and chasing your tail in trying to figure out what the culprit is. I get messaged constantly on PC issues of all sorts, and usually the email goes like this: something happened to my computer, I lost all my data. Something happened to my computer, I'm getting a blue screen. Again, no real detail, no explicit information as far as hardware being used, and miraculously I'm supposed to touch my crystal ball and figure out what is going on, and we know that's just not possible. So what I want to do is make it openly available for you guys to use programs to test your own system, and there's two programs you have to use. Both are free. The big thing here is, and I want to cover this explicitly because I've said it in numerous videos, but for some reason the topic keeps coming up. A hobbyist and a full production machine, there is no difference in. As far as controllers, both of you expect an accurate system. Both of you expect to have whatever you're doing with that robot come out the way you plan. If you're not expecting that, then you might as well tune out of my channel, because I don't build those half-ass type machines. So what we're doing is I'm focusing on two groups. If you're a hobbyist, that's fine. You recreation use, keep in mind these programs are for you as well, because as soon as you load a piece of substrate in your machine, you will find out that if it miscuts or goes crazy or decides to crash into itself abnormally, typically the first thing that most guys do is assume it has to do with the EMI because they've seen my previous videos, and it could very well be that. However, if you run this test and find that your computer does not pass this test, you can rest assured it's the PC's fault most of the time, and I would say most being about 95 to 98% of the time. Okay? Secondly, my production guys, I don't have to tell you, if you're cutting aluminum 6061, you're buying sheets, you got a 5x10 system, large sheet of aluminum, it screws up. How much is it costing you? No different than the guy with the hobbyist. That's why I said it's disillusion, it's like dementia, when guys feel that working as a hobbyist is so much different than working in production. It's really not. It really depends on the hobbyist we're talking about. Some guys that are hobbyists, I know, are more critical than when they actually sell components. Sounds funny, but it's a fact. So what we're going to do today is discuss these two programs. The first program is called Intel Burn-In Test 2.54. Now you can go on Tech Power Up, just do a search, Intel Burn-In Test under Google, click on it. It's going to come up right here. And basically what this program is it's going to overheat the CPU intentionally with process. It's going to stress it. And what we want to do here is stress it to the point of where we're not exceeding what would normally be seen in the highest end user program. And when we say the highest end user program, many of you are saying, well, CNC programs are never that daunting. I disagree. If you're running CAD, if you're doing any type of CAM work, if we're doing Mach 3, we're doing all kinds of math calculations all at once. The other factor many of you seem to ignore, and I've seen this numerous times and I don't know why this is that you don't take into account temperature. Ambient temperature of where your system is going to play a tremendous role on how stable it is. If you go into a commercial CNC facility, you're not going to find that there's no air conditioning, that these systems are just, grease all over them, they're sloppy. You got a $250,000 Haas machine, it's going to be golden, because usually the business owner / programmer / end user will realize exactly what investment that company has, and they want to make sure that machine is pristine, as I would hope many of you would. So again, always factor in not just the PC itself, factor in the ambient temperature of the environment it's running in. And the beauty of these burn-in tests are not only just stress the hardware in terms of the memory and CPU usage, but it's always going to stress the actual heat production and how well the computer can handle that heat production in an environment that many of you may not consider, especially in states where it's ridiculously hot, and I hear it over and over again. Many of past clients and potential clients feel you don't need a climate-controlled environment, and I totally disagree with that. Okay, we are dealing with a machine that is a robot. It is not a machine that's designed as a drill press, as a scroll saw. This is a robot. So again, when I hear guys contact me and tell me about steppers are hot and this are hot, of course they're going to get hot naturally, but when they're in another 100+ ambient degree temperature, how much hotter are they? How come parts fail prematurely? That's why. So what we want to do here, again, we're going to use LinPack from Intel. And basically what LinPack does is it's going to take your x86 or x64 processor. And again, we don't have to get into technical terms here. I don't want to go back into exactly what makes up a 64-bit, what makes up a 32-bit processor. The only thing you need to be concerned with is how to run this test, what parts of the test are important, and what parts of the test are going to work. So you're going to download this. You'll come over here. You'll click this. Select your server from where you'd want to download it, and it will be in a zip file. Now once you have this program done, we're going to go back over and we want to download Open Hardware Monitor. Now some of you guys will be lucky enough to have a hardware monitor on your system that may have come pre-installed and you know how to run it. And the hardware monitor is so that we can see what's going on as far as temperature and voltages with our CPU and all the cores of our CPUs, and we want to basically analyze all the temperature of the system, because once we run that LinPack associated with Intel, it's going to turn up the processor's use at a maximum level. We are hoping to find instability when we run this program, because if we find instability, we can then prepare in a simulated fashion for never having that happen when we're running a program that is critical, like when we're machining. Makes sense, right? So essentially, what we're going to do once you download this, and again you can see here you can also donate. It's a great program, free, again very simple to use. You're going to download it, click the link, and you'll go from there. If you need the actual website, it's openhardwaremonitor.org. Okay, very simple. Once we download these pieces of software, you can see I've got them on my desktop. Here they both are. And now to run, first we're going to run the Open Hardware Monitor. You can see right here, we're not going to buy anything. We're going to go to Open Hardware Monitor, double click, and then openhardwaremonitor.exe, double click on it. Click on yes, and it'll pop up. You can see my laptop here. I've got an Intel i7 4710HQ CPU, and being she's quad core, you can see all of the cores, and those are individualized. The beauty of this is that you can see here what the Celsius temperature we're running on our processors individually per core. Okay? Load on the cores. You can see where we're running right now. Power, CPU package as far as wattage. Okay? Load on the memory, 24.9%. Now I've done a video on a similar program, and I also have that installed as well. And that is System Explorer. This is a little more detailed because all we're doing now is we're trying to load and review the load that we're placing on the system when we run the Intel burn-in test. Because what we're trying to do is see if this stable can handle the stress at maximum level, more than we'd ever achieve in a normal program environment, so that we can see if it's stable. Now, before you run any simulator test, we want to make sure that your PC is placed in the exact environment that it would be under normal use. And why we want to do that is because, once again, if you're putting it in your cozy house at 70 degrees and then we go outside in Vegas and you're in your garage at 105, we want to make sure that that temperature variable is included when we run the program. Okay? So what we want to do now, click on our Intel burn-in test. You can close this out. Intel burn-in test. Double click on the exe. Once again, do you want to allow this app from an unknown publisher to make changes to your device? Click yes. And now you see it came up. Now, these are the two pieces of software that will be required to run this test. And just so everybody is aware, these two pieces of software are typically used by PC gamers who overclock, and that term overclock means that they take their CPUs and memory and typically run them above stock speed. So it's like taking a car and putting a turbocharger on it and doing a dyno test to see if everything is stable with what associated hot rod parts you've installed. This is no different. The difference is you're not doing all of the extracurricular activities to the system in order to make the performance higher, so to speak. We just want to make sure everything is stable with what we currently have prior to us loading Substrate and attempting to cut to make sure the system can handle what we're trying to do. Okay, so stress level here, you can see it's set at mode 64, and that's because it's going to auto-detect whatever architecture your operating system is. If it's 32-bit, it'll say 32-bit. If it's 64-bit, it'll say 64-bit. Your stress level. Now, we can go with custom, we can go maximum. I highly recommend going maximum. And the reason we say that is we always want our actual testing to exceed any program we would ever run at any time. And if we're running multi-core CPUs, as my SIF system is and many older systems are, even if you're running an Intel Core 2 Duo or older type CPU, or for that matter, even an AMD multi-core processor, this is imperative that you always want to go maximum, because if you guys ever multitask, and many of you do, and that simply means opening up more than one programs at once to do two things at once, so to speak, this program will once again give you that feedback to know if I run maximum stress test, I know for a fact that my system will never reach that level of use, and therefore everything underneath it will be stable. So again here, available RAM, and you see this number constantly changing. And it's changing because of back processes that are actually going on in the background. Okay? So when we click on maximum, it's selecting the maximum amount of memory in my system. Well, that will not typically be allowed because your system is not going to allow you to allocate it. So in this case, I'm going to go to custom. Now I can allocate how much memory I want the test to include. Okay? And the reason we want all the memory we want to use in this test is we want all the CPU horsepower, all the memory power available, so we can once again simulate that load at the highest level, so we can see exactly what effect it has on the system. Okay, some other quick areas to discuss here is the checkbox for output results to results.log. If you check this box, you will get basically a log file. Once everything has been completed, you can see here once again you've got your results, speed, G-flops, all that neat stuff. The main area we're concerned with is this freeze test, once again with the avatar for the flames. Another area you can adjust if you so choose is the thread count used for your CPU. Now, under general use for our applications, I highly recommend leaving this on the default setting of all. This way we get the highest stress on our system available. That's imperative. So I'm assuming now you've done the right thing and already put your system out in the environment where your CNC chassis will be located, or where you plan on running everything. Once you have that, you can see here, take notes on the values of where your CPU is. You can see right now my value is right here, CPU core. I can check everything here. You can see your bus speed, CPU temps. These are really the areas we want to stay in. You'll stay here with load, and we'll stay here with temps, and these are going to change dramatically once I click on run, more or less, or in this case start. Time to run, 10. I don't recommend changing that. You can change it longer, but typically if it runs 10 cycles and the system is stable, you're golden. Okay? If it locks up or you have some weird things happening, you'll see this little avatar here as we start it. It'll start acting like the flames are wiggling. If it stops, it's letting you know that basically the system is not stable. So once again, if we're going to encounter any trouble, we want to encounter it before we hook it up to our machine, so we know not to use the PC. Once again, saving you time, saving you money, and hopefully showing you that, again, that PC that you assumed was perfect, you'll know a problem exists prior to even using it. That's the goal. So what I'm going to do here now is I'm going to shrink down the memory allocation. I got 24,495 being used. I'm just going to go a little bit under that. I'll go 24, let's say 400, just make an even number. Okay. Once I do that, I'm going to click on Start. As soon as I click Start, we're going to once again pay attention over here to the temperatures and the load, and you're going to see exactly what happens. Okay, she's working right now. You can see our freeze test. You can see what I mean by the avatar for the flames. You can see it's in motion. And you can see, if you look at my temperatures, they're starting to climb. CPU load, see how the load's going up? We're at 100% on all cores. CPU wattage, everything is going up. So now you can see exactly, similar to what a car would do with a dyno, you're seeing everything internal of your PC. It's letting you know what's actually happening. Now you can sit here and watch this thing. It'll usually run for about 3 to 4 hours. Why do we want to run 3 to 4 hours? The longer time we have where this software runs stable, then we know that we have a longer defining factor of stability for what we're trying to do. Some guys may want to run this even 20 times. You can set that number whatever you'd like arbitrarily, but typically, like I said, 4 hours is plenty. The main thing is that you pay attention to everything we have here. If you're dealing with an older PC, the main thing you want to look at is make sure everything with your heatsink around your CPU is clean. Dust will negate any cooling. Okay, so we want to make sure all of our cooling fins are clean, make sure all the memory is clean. I've done a video on deoxit. This is where all those neat little electronic additives come into play, because all of this will aid in making everything as stable as possible in the long run. Because again, it's not one variable, it's all of them. So you can see here how we're climbing. We're climbing steadily. Temperature goes up, goes down, and then you'll just see it keep climbing. Processor usage will keep fluctuating, and the wattage will keep fluctuating. Once again, if you look at our memory load as well, you can see it's also going way up. And that's exactly what we want. Because the overall goal here is to make your computer as stressed, once again, more than it ever will be, because we know in this case, once you load Mach, or Mach 3 or Mach 4, regardless, you see CNC, Centroid, whatever motion control software you want, we then have that peace of mind to know the system is stable. Okay? Once we know that, then we have different variables as far as if you do have troubleshooting, you can then go in and say, you know what, I've already done this test. I know that the system is stable. You've eliminated it. Okay? So I'm telling you right now, I hope many of you watch this video to the end, because after I'm done with this, I'm going to cover with you a backup XML file that's created automatically in Mach 3. Many of you don't even realize. And I get questions on this all the time. Oh my God, I lost everything. My hard drive crapped out. Again, we have to educate ourselves with due diligence and hold yourself accountable. I mean, I cannot emphasize that enough. I am not there with you guys. If you don't message me complete messages, I can only answer what is given to me. Okay, and I only work with variables. As an engineer, that's all we can work with. So when you send me, hey, I don't understand what this is going on with the system, well, neither do I, because I'm not there with you. So videos work really well. Extreme pictures, extreme detail. It may take you an hour to put together a message. It takes me 2 hours sometimes answering them. So we have to look at that. But overall, you can see here, again, LinPack output, time, seconds, speed, G-flops, results. This will be populated as we go, but overall you can see exactly what's going on here. Right now, you can definitely feel on the exhaust fan of my laptop, it is smoking hot. So it's definitely doing what it's supposed to do. Again, you can see your wattage is being used, and it's pretty amazing how running this type of simple test could save someone's bacon real quick and a lot of money, with the hope and the dream that, hey, this PC I just picked up at the flea market for 40 bucks is going to work great. Well, we're going to see. Because if it does this, and it could very well work fine, but I would rather, like many of you, be certain before I lay down a sheet of whatever I'm cutting. I've had guys do, Stratocaster guitars, and they're doing, real high-end woods, and lay it down, and that same guy's a hobbyist, and he's like, oh man, I've had this wood forever, I'm going to do this, and then he lays it down, and boom, computer freezes, there goes your system. I don't care if you're using a servo or anything else. If the computer has a problem, it's the neurological center of CNC, and I've said this before. Okay, the first letter in CNC is stand for computers. So again, we have to look at that and analyze everything at that level. This will take that variable out. So what I'm going to do now, and I want to clarify this again, if you guys close this program, now this program you can close just by Xing it out. If you close this program, it is not going to stop. It will run in the background. And how do I know that? Well, watch what happens if I close it. You can still see processor is still at 100%. Okay? What's really interesting, if you come over here to System Explorer, where I've discussed in previous videos, you can see it's also at 100%. So it's showing you everything here is normal, but unfortunately we're still running the burn-in tests. So you can't just simply hit the X in the top right corner and exit out. What you have to do is hit Control-Alt-Delete, bring up your Task Manager. Once it opens, you're going to be searching for LinPack. It went too far. Better populate. There it is. Here she is. And you can see here, 100% CPU, it shows you everywhere on the PC. It knows something is going on. Okay, so I'm going to click on that, End Task, and then you'll start seeing everything come back down to normal. Okay, it's closed. Once that program is no longer listed, you're golden. And then what we're going to do is watch, and you can see our CPU is now coming back to normal. Wattage is coming back to normal. CPU cores are returning or lowering in temperature. And then, of course, over here, load on memory is once again decreasing. Now, you can see here under max value, what that is the recorded highest temperature and the highest load and the highest wattage of everything that has been recorded. Okay, and the thing about an i7 is it throttles the CPU up and down, and that's what you're seeing here. That's why we're at 33 and then we're at 34. So you can see exactly what was going on. I highly recommend when you're done taking a screenshot. You can do it with your cell phone. You can do it with Snagit or whatever type of program you're using, or even record it manually by hand and date it, stating that the system passed this test, and then you have that variable covered, knowing that the knowledge is there, your system is stable. Now, as far as Mach 3, let's see what we can do with Mach 3, because I get this question all the time by you guys. We'll go in, we'll say Mach 3, and you can see here there's an XML Backups. Now this file is created anytime you install Mach 3. And you can see all my backups that have been auto-created, B21, 22, 23, 24, and numerically on and on. If you click on the README text, this directory is used to hold backups of your XMLs as you change them. If you would like to use one of the backups, simply change the file's extension to .xml and place it into the Mach 3 directory. That's it. So if, God forbid, you guys forget to do something and the system will boot, you still have these backups available. I've covered this in a previous video, but I still get questions on this. I highly recommend buying a cheap flash drive, 8 gig, 4 gig, they're dirt cheap, and doing a backup of any critical files you have, especially cut files. If you're doing DXFs, if you're doing Vectric or whatever CAM software you're doing, back up your drive. If you don't do that, guys, your whole livelihood could be toast really quick. So again, take the time, take the investment, and do that. I mean, it's imperative. But again, if you ever want to know if you have a backup, you do. And this is in Mach 3. I'm sure Mach 4 is the same. I haven't checked it in Mach 4, but it should be there. This XML backup folder is just amazing. And you can come back to even loading one of these to see, and you can actually rename them. I'm pretty sure that should not affect anything. I mean, you can name it what you want, just don't change the .xb25, 24, so on and so forth. The cool thing with this is it will allow you then to even try different settings. So if you wanted to try one setting for one substrate and another setting for another substrate, different feed rates, so on and so forth, you have all of that. Or if you're running multiple robots. I have many clients that have multiple machines in their shop, and you can do backups and label it for each individual robot to tag them, so to speak. So again, I hope this video has been helpful, and I know I've probably generated more questions than answers. It happens all the time, and I expect that. If you guys have any questions or require quotes, once again, message me direct at storm2313@gmail.com. Again, if you guys need consultations, and I'm getting a lot more requests for consultations because, like I said, clients or potential clients have come to me with, unfortunately, system crashing issues. I've worked on many, many systems, and again, dealing with PCs, they're all different. I don't care how old it is, how new it is, they're all different, And again, each system may have different programs in it, could be running in the background, interfering with things. So certain things you may understand, certain things you may not, and that's why I said, being a mechanic without the car in front of me, most of the time a team viewer consultation will allow me to have access to your system. We can go through it together and identify the problem, rectify it, and get you up and running. If that needs to be done, of course, we can do that. Please message me. Again, you'll see that information on the screen. To all my subscribers, guys, I love you. We are definitely growing. The channel's getting crazy big. I mean, at least for me it is. And I'm just trying to keep up, so please bear with me. Thank you all for your support. Take care.